Welcome to GradCast, the official radio show and podcast of the Society of Graduate Students at Western University. I am your host, Nick.
And I'm your co-host, Ariel Frame.
And today we are here with Xiaoshen Zhang, who is from the Department of Geology and Planetary Science. Thank you so much for being here.
Thank you for having me.
So why don't you tell us a little bit about what you're doing at Western? You're a second-year master's student, correct?
Yes. So I study geology and I focus on the lunar geology. And specifically, I focus on lunar regolith, which, for people not in the field, they usually say lunar soil. And my interest eventually is to work with like how to use lunar regolith and turn them into construction materials so we can build lunar bases, lunar houses, hotels, roads using local materials.
Okay, this is super cool because I'm a huge science fiction fan, and whenever you read any science fiction book that takes place on the moon, they always talk about regolith. Like it's like the word that pops out like every word. So I'm really excited about this episode, and what you're doing is like very sci-fi like. So tell me what it is exactly about regolith that's so special.
Well, regolith it's everywhere. And it has, depending on the locations on the moon, you can have different mineralogical compositions. And if you go to the poles, you might even find some ice mixed with the regolith over there. So really, depending on where you go and why you're going to each location, you can pretty much use the regolith at that location and process them into things that are going to be useful for humans.
If someone had to ask you, what's the difference? Like we make stuff out of soil on Earth, and isn't it the same here? Like what's the major barrier on using the regolith that's different from the resources that we have here on Earth?
On the moon, it's harder to work with regolith because the gravity there is much lower. So if you just start shoveling regolith, you might have them flying everywhere, right? You don't want that to happen, and you want like when they are flying, they might block your vision, and they are actually pretty harmful stuff. And if they get into your spacesuit, it really is not good for your health. So but then it's there, which means we don't have to bring the material from Earth to the moon, because that's going to cost you a lot of money. Even though we have reusable rockets now, it's still going to be very expensive. So using local resources, or what we say like in situ resource utilization, is going to be a very economic solution for prolonged human exploration missions.
And tell me exactly what this is made of. Like what is the material comprised of?
This goes back to the history of the moon, and so there are 3 or maybe 4 major mineral groups: olivine, pyroxene, and plagioclase feldspars. And also there is like a minor kind of mineral group called creep, because K for potassium, REE for so KREEPE. RE is rare earth elements, and P is phosphorus, and they are concentrated at some areas on the moon. And so when you're looking at the moon, you see dark spots and whiter areas. So the darker spots are called lunar maria. Mari for Maria is the plural form, and Mari is the singular form. And those are stuff from like lower crust or even upper mantle of the moon. And they were formed because of volcanism, or maybe in the past when the moon just got formed, there were like a lot of huge asteroids or other impactors just smashing into the moon and eventually extract those deeper materials out. So, and then when you say regolith, it actually doesn't mean like the soil or dusty part. If you find a boulder or rock on the moon, those are also categorized broadly as regolith, right? So It's just whatever is on the surface of the moon got broken down by multiple, or more than multiple, endless impacting events and space weathering, like solar radiation, and broken them down, and it's just whatever is on the lunar surface.
You know, one thing comes to mind is that like when I'm imagining sci-fi, I'm imagining also like bubbles where we have to put oxygen. So if someone wants to live there for any period of time, we're gonna have to be able to breathe there. So you've got this bubble, and then also in these sci-fi movies, they always have like somehow gravity in this area, like the gravity's stronger. Are people thinking when they're wanting to think of ways to use this regolith to build? And you said there's an issue that the gravity, if you pick it up, it might float around and damage equipment and damage people.
Mm-hmm.
Is there some effort, or would it be a good idea to like create this bubble? Is that unrealistic? Create gravity somewhere, more gravity somewhere, so that you could then build, or they just, we got to build regardless of the gravity issue.
I don't think that artificial gravity would be possible in that way, but I think a lot of people are designing robots to send them first, and to help with building whatever we need, landing pads and maybe simple roads and lunar bases, so we don't have to exactly use humans to do all that work. Yeah, but sorry, what was your question again?
I guess it wasn't quite a narrow question. It was more saying like those that might say, don't worry about that issue of the gravity thing, because we'll deal with it later by just adding gravity. Is that even a realistic thing? But it seems like you're saying it's not.
I don't think so. I've seen like what sounds more possible to me is like some people say they could create artificial gravity on a space station, for example, if you just like rotate them and somehow creates artificial gravity and not make you dizzy. But on the moon, I don't think so. But a fun fact is that there has been some areas with a gravity anomaly. So in general, like on average, the lunar gravity is 1/6 of the Earth. But some past missions, like NASA's Grail mission, have found these mass concentrations or mascons, and at those mascons, they find the gravity a little bit higher there. So that's a really interesting phenomenon to me, and I want to know more what happened. Why, like, is something crash into there to make that area more denser? Because that's what's related to gravity, right? So it's really interesting. But artificial gravity wise, I don't think so. I hope people can make it real, but we'll see.
I'm just looking at your background there, and I see that you have a couple of posters of the Earth.
Yeah.
So what is the reason why we want to go to the moon and we want to set up a colony there?
So a lot of, there could be, because humanity is like, we like adventure. That's just in our character. We keep exploring the frontiers, the impossibles, and we keep learning, so space exploration, basically, because the universe is full of unknown, and that's what makes it so exciting. And like a lot of small children, and I guess when you were younger as well, like when we were children, I think a lot of us were interested in space, because space just what's the word, just stimulates your curiosity. And I think it's just really exciting to get out there and see what kind of environment that our planet is situated in. But in another kind of more sad kind of way of thinking is, how dinosaurs went extinct? they didn't have a space agency. We are like, because in early ages of the solar system, impact events were really common, but even now it's still really common, and we never know if something could happen to us in the near future or in the longer future. So being prepared is always just a good option, I guess.
Mm-hmm.
Yeah, but this doesn't mean we are actively abandoning Earth. We want to still protect the environment here,
Mm-hmm.
and we just want to go a little bit further and make traveling more exciting.
Mm-hmm. That's really interesting. I think like space is so cool even as an adult. So I'm really
Yeah.
like, and I'm so excited there's sort of a renewal in space interest. I want to go back to the regolith for a minute. You said that there's a variety of kinds, on the moon, and that it's sort of a broad term. And you're focused on making an artificial version of it. So how do you choose what kind to make, and what's your process like?
So first of all, there's already like 36 or even more than that made across the world, and so I've been studying some of them in the past few years as well. And so I just said on the moon, the three major mineral groups are olivine, pyroxene, and plagioclase feldspar, and we can find all of them on Earth because the moon, so far, it's widely believed that it's formed from a giant crash of something as big as Mars crashing into early Earth, and the debris kind of just like rotated together and formed our moon. So that's why there's a compositional similarity between the two bodies. So we can find rocks and minerals of similar composition here on Earth. For example, the darker spots on the moon, the lunar Maria. We usually, if people want to make something artificial that simulates the material found in lunar Maria, they go to find a volcanic field and just sample some volcanic ash and scoria, those kind of things, and just process them just crush them, for example, into fine particles. And that's one of the most common ways to create a simulant. And same for the plagioclase, which is the most abundant mineral group on the lighter shaded areas on the moon. So you can all find like similar things on Earth mineralogically. So finding the right composition, whatever you want, and just process them. It's the most common way of creating the simulants. And yeah.
So are you working on improving people's way? I mean, it sounds like you're saying this is how people do it. Are you doing? Is your research furthering people's efforts in simulating this better? And how so?
In a way, yes, because the lunar regolith. So from now, when I say lunar regolith, I mean what people usually refer to as lunar soil, like the finer particles. So they are extremely complicated, actually, even though there is a mineralogical similarity, but because of the cosmic rays and the solar winds implanting, and then all of the impact events happen in the past, a lot of like material mechanical properties, for example, are different from what you just crush the rocks from Earth and you get it from. So why we create simulants in the first place is we want to test technologies that we want to use on the moon. So for example, if you want to send a new lunar rover, you want to test if this wheel can stand the regolith there, or if you want to say, in my case, if I want to build a house on the moon, I want to test if whatever like my technology could work with lunar regolith. But we don't have enough of that on Earth. We have maybe 400 kilograms returned from Apollo program. And so that's why we're creating artificial ones on Earth. But because the lunar regolith, like the actual lunar regolith, is so complicated, it's really difficult to simulate multiple properties. And sometimes it's easier that you're focusing on just, for example, the particle sizes, and sometimes maybe the density, but maybe you're ignoring the mineralogy, or maybe you're ignoring the some other geotechnical properties. So that can make your production of simulants a little bit easier. But if you test your technology using these simulants, you might find your results not so accurate, right? So, and then if you design your technology according to these results, maybe they are not going to function very well when you're actually going to the moon. So in a way, I did, like in my previous thesis, I did compare several types of simulants and say, because a lot of people probably are not aware how different simulants can be. So I kind of made a comparison and be like, hey, look at type A, and this is better for these kind of tests, and type B is good for a few other kind of tests. And if you're using the wrong ones, you can make bigger mistakes in the future. So in a way, and then for now, I am still investigating a few other properties that are usually ignored or maybe difficult to create, and see if ignoring these properties could make an impact in your tests as well.
Can you tell us what those properties are, those new ones that you're looking at?
So one of them is not quite new, but it's about the mineralogy. A lot of people focus on just the chemistry, like if they find enough like chemical element compositions in the simulants, they might think it's enough. But a lot of times, minerals are, like chemical elements, like atoms lining up in different shapes, and then they could control many other types of properties. So if you're just focusing on the chemistry but not the mineralogy, you could get inaccurate results as well. And another thing is about impact, because as I said, the moon received a lot of impact events throughout its entire history, and that could make the particles deformed, so they might be more fragile, and maybe chemically also got altered as well. And this part is something I'm really struggling to find information about. But I guess that's why we do science. We find a curiosity, and if we don't have information, then we find out ourselves, right? So I want to see if impact events could have altered some properties on lunar regolith as well.
Is it possible that if we go to the moon and we bring some of our own compounds, minerals, something to mix in with the regolith there, that may help it be more usable? Is that something anyone's thought of?
This reminded me of a recent study got published, I forgot, maybe around the end of March or something. But so a lot of people are thinking about 3D printing to combine, I'm not sure exactly like how, but they want to use 3D printing robots and then combine with regolith to make durable materials. And one interesting study found out that if we send humans to the moon, and we can probably use urine to like human urine, I'm not kidding, to help with the 3D printing, because like in urine, like the most abundant compound is water, and then the second most abundant is urea. And urea apparently is found to break down hydrogen bonds easier, and that could kind of dilute the 3D printing material. And otherwise you need a lot of water, and you can't find a lot of water on the moon, right? So I don't know how exactly they plan to put this into real applications, but it's a really interesting example of how we can, bring something from Earth and use it on the moon.
Well, I mean, it seems like there's many exciting avenues in lunar research, and this is
Yes.
just an example of one of them.
Yeah.
So one thing comes to mind, how did you said that, everyone as a kid was interested in space. I don't actually remember being so particularly fascinated with space myself, but I've always been fond of science fiction, and you can't have too much science fiction without space involved. What got you first interested in this space sort of thing in a research capacity, and what was your path in getting to where you are at Western?
This is a long story. Back in university, like my undergrad, I did geology at Waterloo. And at that time, I was not really interested in finding a job in that industry, because I think a lot of people might think about, mining companies or oil and gas. And to me, that's not something I really particularly wanted to do. And but I did have a general interest in space since I was little. I remember I was probably in even kindergarten, and my mom drew me kind of a little diagram about the solar system. I'm like, wow, interesting. And so after graduating from undergrad, I went to work in Japan for 2.5 years. And it was during that time I got hooked with this anime / manga called Space Brothers, and I recommend that to you as well if you don't know it. And it's about astronauts, really. But it's got supported from JAXA, the Japanese Space Agency, and maybe something from NASA as well, because a lot of the content is real, it's true. So that is something that got me really interested in the space sector in general. And so I wanted to kind of change my career path, because at that time I was working in Japan as an educator. And also that experience kind of made me feel how important education is. So I decided to go back to school. And I found the International Space University, and I was really interested into learning more about the space sector. And frankly, at that time, when I even got into ISU, I didn't know what I want to do in space later. I just wanted to know I want to be in this sector, but what exactly can I do in space? I didn't know. And it was during that year, my first year there, we had to do, like, each of the students had to do an individual research project. And there was like a list of topics ready for us. And there's one of them, forgot the exact title, but it's something like the primary locations of interest on the moon for future lunar settlements. So I decided to take that one, and I just did a lot of research, and eventually that got me realize that I didn't know, but we are studying the geology of other planetary bodies already. So, and then because I do have a background in geology, I decided to then study lunar geology, and I wanted to come back to Canada eventually, right? So I did some searches about planetary science here in Canada, and found Western, and I'm here.
Nice, you came back home after all
Yeah.
that. But surely you didn't leave the manga behind.
No, I went to Japan earlier this year as well, and I even bought some of the newest issues. And yeah, it's a really good one.
Cool.
And so now you've been at Western for 2 years. And,
Yeah.
and how are you enjoying your experience here so far?
I think it's really exciting, because we just started the Institute for Earth and Space Exploration last year. And so that means there's going to be a lot more opportunities, and maybe more labs, more instruments for us to use in the future. So I think it's kind of like witnessing a little child growing up, right? So I love the people that I met here. They are really helpful for me. The topics of my research are kind of not being focused right now at Western, but I think it is in the plan. Space resources, for example. So I do look forward to seeing more. We'll get more involved with other researchers in the future, or just seeing Western grow in the planetary science researches.
We're running out of time here, but I have one more question. I was sort of wondering what your future plans are after you're done at Western.
Well, I do want to do research. I like finding an issue and find out how to solve the issue. And so right now, I do want to stay in Canada as well, because I want to help with Canada's space sector to grow. And I just want to maybe explore more opportunities and see how I can apply my skills in the research field somewhere in Canada in the future.
If people were really interested in what they heard today about your work, and they wanted to find out more about you, is there somewhere online, social media wise, that they can find you?
Sure. So a fun fact is, during the lockdown, I finally started something I wanted to do for a long time. I launched my personal YouTube channel. It is going to be a personal channel, but I do want to dedicate a lot of content in space outreach. I want to communicate about what exciting things are happening in the space sector across the world. So maybe check that out. And I hope I can get more people engaged in this sector in the future as well.
Just where do they? Search for
that. So the channel name is Xiao Chen, like my first name, Xiao Chen to the moon, and I guess I can send you the link as well, so you can put it on somewhere in the description.
We'll definitely have the link provided below.
Yeah.
So people can click on it.
Yeah.
Well, thank you so much, Xiao Chen, for being on the show. We really appreciate it, and thank you for being here with us on our virtual GradCast chat.
Thank you for having me.
And this has been GradCast, the official radio show and podcast of the Society of Graduate Students at Western University. I've been your host, Nick, and my co-host was Ariel today. And Ariel also produced the show today. If you would like to be involved with the show or get in contact with us, you can email us at gradcastradio@gmail.com. You can also follow us on our Instagram, Facebook, or Twitter at GradCastRadio. To listen to us, we're on the radio at CHRW 94.9 FM. You can find all our old episodes at our website at gradcast.ca or on podcast apps like Podbean, iTunes, and Spotify. We also have some podcast videos at our YouTube channel at GradCast Radio. Thank you so much for listening, and have a great day.